Alright, so solving linear inequalities. Okay, this is actually pretty similar to solving linear equations. Okay, hopefully this will start ringing some bells once we get into this. There is one extra step though that you don't need to do when solving a linear equation, okay, and that's graph the solution set. Okay, so in order to solve a linear inequality, our goal is still to get x by itself, just like it was when we solved a linear equation. Right? So what we're going to do first is just pretend that this is an equal sign, basically. Okay, I want to get x by itself. What would my first step be to get x by itself? Subtract 4 from both sides. Subtract 4, so we get 2x is greater than 32. Now what? Divide by 2. So we end up with x is greater than 16. Okay. So that's how I express my solution set. Okay.
You have Elijah in here.
Yes, I do. All right. Now, the new part. Okay. I mean, I guess this is a little bit new. Okay, but the big new part is graphing the solution set. Right? Does anybody remember how we would graph something like that? Okay, we're just using a number line. Okay, not a two-dimensional coordinate plane, just a one-dimensional number line.
Isn't it? You have like isn't it like with the two arrows or something? Would this one be an open circle, and then just like 0 and then open circle 16 or something like that?
Yeah, you're definitely on the right track. So
why not? You start at 16.
Isn't the open circle not included?
correct.
And
Yes.
Then the closed circle is included.
Exactly. Right? So that's what Kayla just said is this little note over here. Right? If we have just less than or just greater than, right, without the little or equals sign, that's when we use an open dot on our number line. Okay? If we are including that point, right, we're saying it's or equal to, that's when we use a closed dot. Okay? So if I wanted to graph this solution set, okay, usually what we do is mark 0 on the number line, and then mark where our value is. Okay, 16 is going to be to the right of 0. So I'm going to just mark 16 over here somewhere. Okay, you don't have to count out every single spot. You don't have to mark 1, 2, 3, 4, 5 all the way up to 16. You just mark 16. And then this x is less than 16 or x is greater than 16? Greater than 16. So am I going to, I know this is going to be an open dot, right? Because it's not or equal to. Now, is my arrow going to go to the left or to the right? To the right. And we're saying that this is greater than 16. So every single number that's greater than 16 would satisfy this inequality. Every single number greater than 16 is an answer.
You sure?
Sure.
Yep. Even Kajillion.
Even a cajillion. Okay? That's why we need to graph our solution set. Okay? Because our answer isn't just one number like it was in an equation. Our answer is a whole bunch of numbers. Okay? Our answer is every number greater than 16. Okay? 16 and a half, 17, 28, 9,422. Right? Those are all answers to this inequality. They all make this inequality work. Okay? Every number greater than 16. Okay? You okay with that idea? All right. So let's take a look at another wrinkle here. Let's try to solve this one. And then again, graph the solution set. So we've got 17 minus 3w is greater than or equal to 35. All right, so what's the first thing I'm going to do to solve this? Subtract the 17 over. Right? negative 3w is greater than or equal to, what is that, 18?
Yeah.
Now what?
Divide the negative 3.
Divide the negative 3.
6.
And I get w is greater than or equal to 6, right? Or negative 6.
Where did you put the sign?
Exactly. Right? That's the wrinkle here. Okay? Make sure that you fill in that little note on your paper here. Okay? When you multiply or divide by a negative number. So in this case, we divided by negative 3. Whenever that happens, okay, whenever I multiply or divide by a negative, I have to flip the inequality. So it did say greater than or equal to. When I divide by a negative, I have to flip it, right? And make it less than or equal to. Right? So my answer then is w is less than or equal to negative 6. So how would I graph that solution set? Exactly. And so we'll mark 0, put negative 6 over here. It's less than or equal to. So Jada said we make a closed circle, and then our solution set goes to the left. Yeah. Okay. What do you guys think? Easy.
You're talking about the ceiling.
I'm not about to slam you.
This Brian has broken my math teacher trust.
Alright, I mean, we can throw other things in, like you may have to distribute or find like terms, like, you know, the types of things we did the last couple of days with equations, right? But that's as hard as these are going to get, right? So any questions before we try some here? All right, then go ahead and start trying. I believe there are 8 more on your paper. All right, let's go over a few of these.
Yes, let's get them right.
What's up, Mr. Moore?
Not much, just walking around.
Cool. All right, so I put the first 2 up here on the board. Okay? On number 1, okay, we needed to make sure that we flipped the inequality because we had to multiply by a negative number. Okay? I bet you some of you forgot that. And on the very first one, we had that instance occur. Right? So these are our solutions to the first 2. We're not going to go through all of them together, so I will take questions on any that you want to look at besides these 2. Okay? We don't need to go through all 8 of the other ones together, but we will go through a couple of the other ones. Okay? So which of the other
10.
8 do you want to see? Number 10?
10.
Okay.
Are we going to go 15
10,
16?
straight.
Yeah, we're going to do 15 and 16 together. Okay, but so of those first 10, number 10, any others?
Come on,
No, dog.
Mikey. I knew
Nah, I'm almost done.
you got
Number 5? Alright. Let's start with number 5.
But I said 10 first.
Yeah, but 5 comes first in
I
the
don't
order
care.
of
I
numbers.
said it first. I'm older.
Alright, so on number 5, this one looks tricky because we've got a negative in there. Right? But to get x by itself, I'm actually just going to be dividing by a positive number. Right? So if I divide both sides by 3, I get negative 9 divided by 3 is negative 3. But I'm not going to flip the inequality because I divided by a positive number. Right? Even though this answer over here is negative, right? The number that I actually divided by was positive. So I do not flip the inequality here. Right? So then to graph this, this tells me it's going to be a solid dot at negative 3. And I want everything greater than that. Right? So I'm going to be going to the right. Right? So that's what number 5 should look like. Right? Any others before we get to 10?
Can we go over any that we have to put the sign? Like, I just wanna see-
Yeah, let's see which one. Yeah, it looks so on number 7, I believe we'll left to do that. So let's take a look at number 7. Okay, on this one, since I already have my number on the right side of this inequality, I'm going to want to take my variables to the left side. So I'm going to subtract 5z. And 2z minus 5z will give me negative 3z is less than negative 9. So now to get z by itself, I'm going to divide both sides by that negative 3. Okay? So I'm dividing by a negative number here. I need to flip the inequality. Negative 9 divided by negative 3 is a positive 3. Okay? So this is an instance where I needed to flip the inequality because I was dividing by a negative number. Right? So then to graph that, we will have an open dot at 3, and I want everything greater than that. So that's going to the right.
Does it matter which I give this on? I brought 9 over, moved 2 over. Just to make it.
Yeah, that would be okay.
And then
Yeah.
you wouldn't have to flip it.
That's true. Yeah. I mean, that would be an extra step, but yeah, that's perfectly fine.
Bam!
So Mikey subtracted the 2z over and then added the 9. That's perfectly fine. Okay. All right. Let's get to number 10 then here. This one is kind of weird because we actually have to use distribution here. We have to distribute this negative sign. Okay? What we can really think about this as like a negative 1 that we're distributing through these parentheses.
Yeah, it'd be 17 minus negative 1t and then plus 4.
7t minus t plus 4. Right? So now these are just like terms already on the same side of the inequality that I can just combine. Right? So 7t minus t would be 6t.
60.
Oh.
It's like 7 minus 1.
Wait, are you asking me? I thought you didn't work with it. I said 16.
No, I thought you were questioning that
Oh.
7 minus 1. Alright, so now subtract 4 over. 6t is less than or equal to 21. Divide both sides by 6. And, oops, not equals. This is not a nice number, right? 21 isn't divisible by 6.
7
You can divide by 3.
Right, both of these are divisible by 3, so I can reduce this to 7 halves. If you put that in your calculator, though, you would get 3.5, which is okay as well. Okay, you can do that. So on the number line, that's going to be right here, right in between 3 and 4, and I want everything less than 7 halves. So I'm going that way.
Yeah.
Feel okay with those? Yes. All right, then the last ones on your paper, okay, are bringing in kind of the ideas from the last couple of days where we needed to turn a verbal expression into an equation. Right now we're just going to do that with an inequality. So I want to take this sentence and turn it into an inequality using letters and numbers. So it says 19 more than a number is less than 42. How would I write that out?
19 plus x is less than 42.
Sure. 19 plus x is less than 42.
Good job.
Okay, then we do still want to solve each of these. So how would I get x by itself? Subtract 19. So we get x. Do I flip the inequality here?
No.
Why not? It's negative.
It's because you're not dividing by it.
Right, we're not multiplying or dividing. We're just subtracting. Right, so we do not flip the inequality here. And we get x is less than 23. So if I wanted to graph this by hand, I'll mark 0. I'll mark 23. It's going to be an open circle. And I want everything So on this very last one, the difference of 3 times a number and 16 is at least 8. There's a little bit more going on here than the first one. So first, what does difference mean? Subtraction. So it says I'm going to be subtracting 3 times a number and 16. How would I express that? 3x minus 16. Perfect. And then it says is at least 8. Perfect. Okay? Greater than or equal to 8. Okay? That one's kind of tricky to think about, but if you think like, well, I know I've got at least $5 in my wallet, right? That means you think, well, there could be more, but I know there's at least $5 in there,
All
right?
you need for chicken.
That's all you need for 5 McChickens. Beautiful.
Or you can buy a Big Mac filet, a 10-cent filet, or a Big Mac. You can buy right
There
now. Or
you
you
go.
get chicken and beef and $5.
All right. So, real quick, to solve this, we would add 16 to both sides, divide by 3, and x is greater than or equal to 8.
How'd you like the barbecue